to the stream. Uh, Let me make it louder. Make it twice as loud. Okay, that seems good. Uh, yeah, right. Let me increase the limit a little bit. Limit. That's fine. Okay, I think that's good enough. Yeah. Okay, so this is day 13. That's just the title. Let me change the thumbnail to my default one. Okay, there we go. Okay, so what do we have? It's a daily drills right here. Let's create a folder. Daily drill obsidian. We also got this drawing thing, but we never really used it, so did all of that on. And I know the node.h I've been like working on that, but that's fine. I didn't really do any work off stream yesterday after, so yeah. Um, right. Okay, how do I call this? Um, drills, rulers, learning, a main check box. Okay, well, for this one we already finished quite a bit for C because just this file IO. I'm not too file IO, but I know a bit about this. I know a bit about this. I can basically say this is done. These projects will be fun. Write a TCP server. Okay. Honestly, like some of these projects, they could be like my portfolio as well. Let's see what else. Port scanner, packet sniff, socket. We're already here, so yeah. Honestly, we can just well, not all of them, but yeah. Okay, I'll just check them off when we get there, but kind of already know this. Right? I still don't want to check it off. It feels too. This one feels divine. This one even more. This one is like God. It's like because right here, this one is green color. This one is red, and then right here, orange. This is mythical. This is legendary, mythical. I don't even know what this is. This is a top here, and this is somewhere along the lines of this. This is a bit more special, and this one is the best because it says get paid. Okay, life security. And you can tell the way that it makes it, and then the way that it writes that this is made by AI. Yeah, it's fine. This is not like a. This is not a um like step by step. This is just direction. Yeah. So we don't need any crack news today because we already have all of them. But okay, let's do the drills. Daily drill, open terminal, do MV. Okay, let's call it a drill. Then touch, touch. Okay, let me import. Let me go SSH and then do drills. Okay, SSH, copy, score text, go host, press P. Can't believe it's Saturday. Okay, let's go to CD files. I call it drill or drill. I think it's called drills. Nano, and then paste. Control X. Yes. Yes. Clear. Log out. Clear. Clear screen. Go to my VM and then drills that. Okay. We have the file now. Now we can just go to Vim. Then see. Sorry, day 3 here. See. Then we can go to ASM. Then we have this. Okay. Have the file. Okay, let's go. Oops. Include. Accidentally start typing before I press insert. Okay. Includes .io, standard IO. I don't know. For some reason, I don't like saying standard. D3 underscore. But no one asked, right? So who cares if I don't like it? No one cares. Okay, push. It's currently 4:30 right now. So 4:30 in the afternoon. But I wonder what time after that they consider it afternoon, and what time after they consider. I think it's after 12 p.m. they consider it afternoon. No, 12 p.m. is noon, and then after 1 p.m. they consider it afternoon, and from 1 to 6 is afternoon, and from 6 to 10 is evening, 10 to 12 is night, 12 to 2 or 3 is midnight. Then from 3 to 6 is early morning, and 6 to 11 is morning. Yeah, 6 to about 8 is morning. I don't know. Well, I like the fact that from around 3 or 4 to around 6, so it'll be morning. Like I think that's the best time to consider it morning. I don't know why. 'Cause it's just so calm and peaceful. And then from 7 to 11, I just don't like that part of morning. I hate the noon even more. But 2 to 4 is pretty chill. Okay, yapping. Okay, fine. Let's go to D3 underscore 1. Okay, save um sub or speed. Well, I can just say allocate 16 bytes from RBP, meaning RBP was just pushed and right after the sub, so it's going to be directly 16 bytes. That's the max from RBP. And move into RBP minus 4 minus 5. Okay. Int signed int RBP underscore 4 equals minus 5. Wait, I should start writing in hex just to practice. So that would be about FF. That's -1, and then F1, 2. Wait, let's count the bytes 1, 2, 3, and then 4, right? And then if I put a 0 there, that's a 16. If I type a 1, is that 15, 14, 13, 12, 11, 10, 9, 9, 8, 7, 6, 5, 4. Okay, wait, we need a -5. So we need a B. Is this -5? One, 1, 2, 3. Okay, that's 4 bytes. -5 and x2 complement. Yeah, it is. Okay. So why is it that when it's a 0 that it starts with a it's just it's just like it's just the fact that when it's all f's it's -1, right? And if you remove one f, then you're effectively removing about 15. So that's where the -16 comes from. Okay. -10 comes from. Wait, is this 1 1 1 1? That's 8, right? And this is 8. This is 16 in binary. That's 16, right? And then this is 8. This would be 8. That's 8. So if I 8 plus 4 is 12, plus 4 is plus 4 is um sorry, 8 plus 4, 12, plus 2 is 14. plus 1 is 15. Oh, okay. Okay. So I get where the minus 1 comes from. So if you add a bit here, and the last bit becomes a minus. So this is minus 16 plus minus 15 plus 15. Oh, okay. So only the last bit is a minus. And all of these bits, they add up to exactly one less than this one. Which makes sense because if you add one more to all f's, then it would overflow into the other bit. Okay, I understand it. Alright, I understand. By the way, I have an umbrella over my head right now. And the reason for that is because whenever someone walks, since I'm in the basement, I'm streaming in the basement right now. Since when someone walks above me, it drops dust on my computer, and that's not good for the health of the computer. And it drops dust on my head as well, so don't ask me where I'm living, okay? Okay. So this is 10. This is whatever. Okay. We can do this. What is this? Move into EAX. D word pointer RBP minus 4. Okay. Well, let me have another int. It's going to be RBP underscore 8 equals 0x 0x Then I'm writing it in hex so that I can get a feel for converting between hex and decimal. And it just adds the two different values. And then it sets it to, so it moves into it 4. Okay. So 4 plus square 8 plus add that to RBP squared. And then it moves into EAX the D word pointer RBP underscore 12. Okay. RBP underscore 12. Wow, this is easier than yesterday's drill. Okay. Maybe drill 2 will be harder. It's supposed to be, right? Let's see. No, all of them are easy. Well, they are just that. They're just drills. So allocate 16 bytes RBP again, and then allocate 10 x 10. Everything should be decimal. Hex, because hex is my favorite language. Yes, I like reading hex. I can understand everything about hex. Hex is my buddy. I have no friends. Okay. Anyways, move into it. Int RBP underscore 4 equals 3. Int RBP 7. 7. 4x 7. 3. And then we have subs. Hey, yes, the viewer pointer RBP underscore 4 and subs that RBP 8 int. It subs from EAX. So yeah, that's right. Okay. Even though that would be a negative number. Return void int. I think all of these are int, honestly. Int mark as void push RBP push RBP move RBP value of RSP allocate RBP one, two, three. So we need another. Okay, so if if 16, then one would be a one would be one would be 15. Two would be 16. Wait, what? No. One would be 15, two would be 13, two will be 14, sorry. Three will be 13. So just 6 to get A and RBP underscore 8 equals. And then 16 minus y is equal to 3 minus 13 is equal to 3. So 13 is A, B is C, A is 10, B is 11, C is 12, D is 13. D. What do we have? We have move it to EAX, the value of RBP underscore 4, and then multiply with 8. Okay. Okay. Just sneezed. Signed. Side G. NED signed. The other one would also have to be signed int RBP. RBP underscore 12 equals RBP underscore 8. This is if returns a signed int. So signed int as well. This one should be signed in as well because there's no other thing. I'm not sure too much about the specifics of signed int, but yeah. For those who don't have to be signed, but this one definitely does. And D4 underscore, sorry, underscore 4. We have a, time is it? How much time elapsed? 25 minutes. Yeah, let me just like go stretch. Okay. Oh, okay, I'm back. I'm back. Fuck. Okay. I might have stressed too much. Okay, so D3 underscore 4. Well, so we know that we know some stuff. Well, okay, let's think. Dude, I don't need to think. What am I thinking about? Okay, so allocate send bytes. Signed int underscore 4 equals minus 10. Extend is the same thing as ff ff and then f6. Right? That's what it's here. No, wait, what? Oh wait, that's these. Oh, okay, I'm stupid. Yeah, this is this one, not that one. 0. That doesn't have to be signed. That's 20. X20 and int underscore 4 equals 0. Does it return a signed int? No, I think it's the same. Well, there's no difference between a signed int and an int. Signed int is just for compiler to add extra stuff to when printing stuff, like to make it negative, but overall it's the same thing. I don't know. Honestly, don't take my word. 'Cause I don't know. But maybe it checks it when subtracting or something like that. But yeah. Into RBP underscore 4 equals 0. RBP underscore 8 equals 5. Okay. And subtracts those two, and RBP underscore 12 equals RBP underscore 4 minus RBP underscore 8. Let's write that in X. And RBP underscore. This one will be assigned in, but as I said, doesn't probably matter. So into RBP underscore 16 equals 2. And what does it do? Multiplies our int 20 equals RBP underscore 12 times 16. By the way, the compiler would never do this, bro. If it was constants, that would probably just use constants instead of stack space to do that. And then return RBP underscore 20. Okay. A3 is done. And close this ugly mess. And then, let's see. Okay. ls cd day 3 cd dot ls. Okay. Let's go to this. Oh, we're not going to do anything on here. Oh, we are. Agent. This is the one we were working on last time. So we're going to do cd vim agent c. Now we can look. So this is what I was thinking. Okay, so this is really like redundant because I realized that I'm not supposed to be adding a bunch of if statements here, right? Because that just like doesn't do good things. Because we're gonna do this. We're gonna use goto and stuff, and then after we make the C code and everything, then only then we're going to be doing the stuff. Sorry, why? Does that yank? Okay, it does yank. Okay. Let's delete this mess. Okay. And paste right here. Skip. Paste. Insert. Yeah, separate those. Okay, so let's go to Ghidra. Because the thing about that is that I would have to the if statements are really hard to decode on first try. I have to map the whole function and know what's going on before I actually start writing the stuff. Okay, so let's see. So where were we at? Yep, was here. Rename this level. Actually, copy this. Copy. Okay, so we got this part done. Do you have a flush? Yeah, we have a printf and then a flush. Alright, we have a flush and then we have a get car. Okay, so that's where we're at. Okay. Okay, so this is what we're gonna do. We have to let's look at the function, okay? So there's a jump here. Does it ever jump here? Does it ever jump towards here? Xref jumps towards here. Okay. Okay. There's a jump back to here. Enter of this data, and this is to enter username. Enter, enter, pass, enter, 0, enter, user, 1, pass. The thing is, also, can I make this aqua? What's it again? I comments color equals aqua. Okay. I comments color equals light. Change color. Then here it is. And I comment G. Verbose high. I like comment C term. Okay. Wait, I have all the saved stuff. Okay. Oh wait, I don't want to change the comment. I just want to change. Okay, that's good. Okay. And I want to go to insert mode. And now, okay, now we can finally rest in peace. Okay, so let's see. So the way I'm supposed to do it is I'm supposed to map labels. So because I have to map labels because 10169E, right? I have to map labels because it's really hard to do it at first hand with just if statements. So let's just see. Let's just jump backwards. We have to think of that. Does it ever jump backwards? Then it's a loop. This is the first label, right? And then this is the second label. Okay. Hmm. Where does this come from? Jump there. It's get car. Move into their value from AL. Subtract, compare, jump 0. And then otherwise if it's greater than. Otherwise if it's 0. Then it comes here. Hmm. Okay, that doesn't matter. We can map this place. Okay, so let's do this. Well, let's map the other labels too, but let's just go first here, because then we can see the C code. Then we can understand it better, and then we can see what is actually trying to happen here. We can see the comparisons and everything. So after get car, it moves into there. That's fine. It moves into EAX, that subtracts it, okay? Compares it. So I guess we can just do car temp equals EAX temp equals. Because I don't wanna do the same operation like 5 times. Equals RBP underscore 29 minus hex30, which is hex30 is 48. So okay. Let's look at where no termination. I'm supposed to memorize that, by the way. I'm supposed to memorize like the familiar null terminators. I know that I know that 97 is a lowercase a. I think 64. Calculator. 97 minus 32. 65. Yeah, I know 65 is uppercase A, and I actually don't know anything else. What's not the null terminators, I meant the ASCII. ASCII. I'm searching this up on my phone right now. ASCII, what is it? ASCII stabilizers or no? ASCII anchors. Okay, character 0 is 48. Space is 32. New line is A. So basically space would be hex 20 and hex 30 would be the character 0. Hex 41 would be the character A, and hex, what is it? Hex 60, hex 61. Yeah, hex 61 would be the character lowercase a. Okay, so comparing how much, I'm assuming RBP score 29 is you have to enter like a number, because hex 30 is minus a character 0. So if RBP was something like hex 39, then not RBP RBP underscore 29 was something like hex 39, then EX underscore temp would be 9. Okay, it's comparing whether EX underscore temp is equal to 0. No, not 0, sorry. Comparing to comparing to 2 first. If EX EX temp 0 is greater than greater than 2, right? Is equal to 2, go to lab underscore 001017 d7. Okay, go to there. If EX underscore temp 0 equals 0x is greater than x2, go to so if I just put in 2, if I put in 3, then it would go to this label, score 00101892. Okay, if EX underscore temp 0 is equal to 0, 0, and go to lab underscore 001016f4. If EAX underscore temp if EX underscore temp 0 is equal to 0, then go there, and if equal to 1, go to lab underscore 00101786. Otherwise, it's just go to lab underscore 00101669e, because it's just there. Okay, so now you see how we mapped out different stuff. First lab. So now we can just do this. We can call this second lab, third lab, fourth lab, fifth lab. Okay, so now we have different labels and stuff. Remove that. Now we can do this. Okay, so now we can go on to F4, which is the fourth lab. Okay. This is very long, and then this one is shorter. This one is also shorter. Okay. So now we can map out lab underscore lab underscore 0010 6 F4 F4 call this fourth lab. We can space, then we can go here, then we can do this. We can, it loads again the same thing. Okay, so print data underscore. Wait, it's different. It's different. Oh wait. Oh, I'm stupid. All this was doing was just checking if they want to enter username or password. If it's if it's one, then goes here, fifth lab. If it's zero, then it goes here. If it's three, which is greater than two, then it goes to the third lab. Okay. Then it goes to the third lab, which is 8. Third lab is 92, 92, 29, 89. So many labels. Okay. 96, 92, 92. Okay. This is if none of the choices match. Oh, so I'm supposed to jump there, not here. Okay. Not and so what is the third lab? What is this condition for? Greater than to 92 as well. 92 and that one also jumps to 92. Oh, okay. 69 E 8 92 892. Okay. That, okay. Even though I am I already guessed what this function is doing, I'm still gonna map out the whole entire thing. Print data underscore print data underscore. Mm. Also, never do this. I mean, I guess it's fine. Yeah, these two are fine, but so, if you do this inside a label, then sometimes it might be bad. This one, I think it just gets ignored because this is the data and it just gets filled in at the top. Because how is he gonna assign a string as the RO data while running? That's not gonna happen, right? Our data is in the binary. That's just dumb to do that. Okay, so print data underscore. Dude, compilers are actually amazing. I think I should write my own sometime. I just had that realization. Okay. Print data underscore. What is it? Enter username password. Enter username. That's not it. Enter your username. Just enter your username. Enter your username is this one. Paste clipboard. Enter your username. Call this std out. Or no, it doesn't call it. It flushes std out. Flush std out. Then it moves into RDI value of RX and it flushes. Okay. And then it malloc like 64 bytes. Uh, it's hex 64, not 64. So what is that? Hex 60 is 96 in decimal plus 400 bytes. Okay. Malloc that amount and then RBP underscore 28 equals that. How much stores did it allocate? Didn't write that down, but let's see. 30. Okay, that's reasonable. Malloc that amount. And then we're going to so we should read some documented CVEs someday. Okay. And malloc that amount, then puts it there. Rx this value, move into there, side, lead into there, data, which is percent %s, scanf, okay. Percent %s and then scanf. What is it? What does scanf take? Does it take the modifier first and then it takes the buffer? Okay. Well, scanf is unsafe. Wait, jump. I mean, it's gonna find that after we do it, but okay, wait. Let's run the thing in VS Code, not VS Code. Sorry, I mean here, day 3. Let's try to see what GDB break, scan. I guess it won't break as scanf. Break main. Okay, run. And then we're going to do what? We're gonna set this assembly as flavor until access 10i PC. See, we can just let it run. No, stage 0. Okay, break at stage 0. Wow, it just made it look so simple. Like this is the whole thing. Well, I guess we're not at stage 0. That's why. Continue. Okay, and then and and then let's see. Okay, print f pot break print f pot continue. Okay, jumps there. Just break here, I guess. Copy break because I accidentally put a breakpoint at the wrong thing. Continue. XI. Step into. Step into. Go there. Enter username. What was this for? It was for enter your username. 0. Okay, I'm just gonna step into. Wait. I need a. Let me just try to break at scanf at pot. Okay, no. Then access 1020i PC. Printf flush. Loads this thing. Calls printf. Okay, so RIP can be also for data. Compare. Which one are we gonna go to? Let's see. We're gonna go to the fourth one, so and that's going to be for 0. Alright. Yes, we're going to fourth lab, so 0, yeah. F4. Where's 0? Jump. Compare, and then test, and then jump equals. The address didn't change. well, the later parts of the dress. Okay. Did D7 change? Was the second lab? Yeah, it didn't change either. 92. Yeah, F4 and 86, and then jump again to 92. Okay. Hey, what did it print here? Enter username, password, login. Break at this address. List vr. Oh, that's not a thing. Okay, continue. PC. Printf. Okay, whatever this is. Let's see, and then we can also see how it's gonna load the tables. Continue. The GOT offset stuff. Printf GOT. It's here. Oh wait. Oh, it's because I did that. Okay. Let's wait for scanf. Okay, here it is. Okay, so it's that here. It's going to jump here, which is this thing. Copy. It just jumps to the GOT at POT. I mean, at GOT.POT. Okay. Break. And then we can see how this the I think GOT will be replaced. What? Oh wait, break dot got dot pot ISO 99 got dot pot. I mean, it should be that, right? Yeah, because scanf add got dot. Okay, bro, what? Is there not a okay? Copy, break here. So it jumps here, right? X slash and I from this address. Paste. Okay, so it's SAR divides. What is the SAR instruction? SAR instruction. Shift bit to the right while preserving the sign. Okay. Sign division by 2. RSI minus 20. What is in RSI that it needs to do that? And then divides by EDI. Okay. It passes something into the argument. RSI. And then does it have anything else? No. So what is this? Scanf at POTI. And then let's see right here. Okay, so EDI. So RAX is this RBP minus 20, and then it calls. So let's see what's in the stack. Okay. So RSI is RAX. RAX is equal to RIP plus this thing. That's the format percent S. Moves that into RDI. And then EAX is 0, so this should not. And then goes to scanf, right? Scanf, which just jumps. Unless this instruction means something. Indirect branch. Target. No, because they called it. It didn't jump to it. You're saying jump is called? Oh, okay. How does something call a POD? Okay, says define that in address. Okay, jumps here. Which which does that? I did by EDI, and EDI is the argument, the format, and then it jumps if it's greater than. Well, greater than what? Greater than 0? Okay, well, I guess we can only find the answer if we continue. Continue. Program receives segmentation fault. So where did it tried to jump there? ECC. ECC. Is it this? It's not it. 5C8. Where did it try to jump? Did we already jump here? Oh, yeah, we did. End BR64. Which the seg fault makes sense because I know that it's loading some stuff. And it's saying this address changed. But where received SIG segmentation fault. So it instructed this. Okay, wait, can we like restart? Start it from the beginning, yes. Okay, continue. 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 0. Continue. Okay. So step into. Okay, wait. PC x/10i my PC. And then it tries to jump there. Okay, let's step into. Okay, did it receive a seg fault now? Then PC. Oh, it jumped to there. But I thought it would jump there. Is it saying that the next time it jumps there that this will be replaced with that? What is going on? Well, this is libc because I already did printf once. Okay, let's continue then. Okay, here we go. Okay, and then si step into extend step into again, which just jumps there, and this should be libc. Okay, yeah. And when it tries to access these bytes, are you saying that it's gonna do a seg fault? Yeah. Okay, so these are seg fault bytes or something. And then step into yes, step into again. Do okay. Okay, I need Gemini to explain this, bro. Copy. Okay. Gemini explain. It looks like you got the misaligned jump. Jump. Look at the address stored in the GOT at and jump there. Oh, because this is the address at GOT. Oh, okay. And when you performed this instruction, could it be that could it be because I have debugger? It doesn't fire until the first. Okay, let's try that. Run. Continue. continue, 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 0, continue. Okay, wait, let's step into printf as well. 10i. Wait, because they already ran, so what will be the point? So yeah, let's continue. Ni, 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 ni. Okay, bro, it does not work. Is it because I made a breakpoint? Is it because it's a software breakpoint that it doesn't? It's like making it bad. Continue, continue, continue. So which one is breakpoint? If I just do br delete, no, delete, yes. Then if I just run, yeah, 0, enter my username. Okay, so it does work, bro. It does work. Okay. Okay, so it's just, I guess we can just try to search up the scanf. The OC99. Okay. Scanf file. Oh, so it doesn't, I can have any size, so that's the vulnerability. And what it does with my input is also a key to understanding the system and hacking it. Okay, sorry, no hacking in here. Sorry, FBI, no hacking here. Sorry. Okay, let's focus on the task. Okay, so, well, it calls scanf, passes in %s, scanf %s, %s into EDI, and passes in RBP underscore 28. Is that it? And RSI, RDI is RX, RSI is beta. Oh, okay. Wait, it passes in the pointer first. Wait, no, that's steer comp. Okay. RDI is indeed equal to the memory. Move RSI RX. The scanf, it takes in those two things. RBP underscore 20 is a buffer. And yeah. Okay. Or it passes in. Yeah, that's good. Yeah, that, and then move into RDI, the value of RX. Wait, what? Wait, no, that's correct. Move into it, the value Yeah, that's just correct. And then it calls scanf with that. Then it moves into Rx. Okay. So it moves into Rx. Right, let me stretch for a bit. Yo, okay, I just ate and I think I'm lucky gonna like watch like anime or some shit and then work out for a bit. But I'm gonna keep the stream on. Okay, peace. See you. Okay, I'm back. Okay, so now we can continue. Alright, let's see where we at. Scanf, okay. Right after scanf, we have move into Rx, and then we move local underscore 28 into Rx, which is the memory and the buffer that we stuck the string into. Okay. Okay, we can do our what is it? Strcmp, and it's using RSI. It uses RDI as well. Okay, so and let me just do this if temp is 0, temp is 0 equals third comp idea is Rx, which is for 28. The other one is this one. First is showing root. Okay, and if not, jump not 0. If EX is not 0, then it jumps to 92. Otherwise, if it is 0, then you are not allowed to log in. Puts 3. As an admin, okay? So puts if temp if goes 0, then you're not allowed. Then it's not equal to 0. Then it jumps. Go to lab 88, which is just a jump to 92. Okay, so this is a jump to this one, right? Yeah, this is a jump to 92. Copy, paste. Let's go to there. Yeah, that's it. Um, is not equal to 0, then go to 92. 92. Okay, wait, let's look at what 92 is, because it's interesting. 92. So third lab is also 92, right? 1892. This is 1892 as well. Okay. 1892. Okay, that seems to be like the default. Maybe we should do 92 next for the level. Otherwise, it goes to. Otherwise, it calls. You are not allowed to log in. Okay. It says put data underscore. You're not allowed to log in. Copy. Oops. Free. You are and it then freeze, I think. It freeze local 28 RBB 28. Then it just moves it to 0, sets it to 0. RBP score 28. Oops. 28 equals 0. And then this goes back to the first lab. 88. Oh, it's not the first lab. Goes here. This goes to 92. Which is here. Okay, so like alright, so what does it do? It frees it, right? And then it jumps anyway. So what is the point? So I'll just jump there. Is this just here? 92. Okay, whatever. 92. Copy. Go to Control Shift V. Okay. And then let's see, what is this? 86. This is the fifth lab, is it? Copy the fifth lab. Yes. Enter your password. Okay. So print. Sorry, password. Yeah, underscore 00102272. Enter your password. Cost flush standard out. And then malloc with 64. RBP underscore 20 equals this, and then this, and then there's RSI set to RX, percent ice, okay, RX, RDI is set to percent ice, percent S, and then RSI is just set to local 20, okay. So loads in RBP underscore 20, okay, so scanf again, percent S, this time local RBP underscore 20, and then now what? Scanf, and then it jumps. Okay, jumps to 92. I recognize that 92 is here, the third lab. This one also jumps to 92, right? Okay, so all of these jump to 92 anyway. Okay, go to 92. Two. Which one? Okay, wait, go back. D7. What is D7? D7. Okay, second lab. Should be label. This is the third lab. What's lab? This one is the third lab. Okay, so no matter what input that we put, it's always going to the third lab. And if it's also wrong, then it also goes to third lab. Okay. Got it. Okay. And this is the second lab. Second lab. Okay. So it moves local 28, which I recognize that's the pointer that we used to have. It moves the stuff in there. Okay. Does it ever go to second lab? Test EX. What? Second lab, right? Yes, it never goes to second lab. This is where it actually makes this. 857. Jump not zero. Please try again as admin. Oh, okay, it's the login. Oh, okay. But if you just search comp, this is empty, then I guess that this is nothing. Okay. Understand. Yeah, some of these like look like logic errors at the get-go, but then you realize it's not really. It is true that this should be initialized. Okay, so this it stir comp and then RBP RX times RDX, which is this root. Yep. Okay, what do I call it? If equals just for comparison. Okay, so I'll just strcomp, and then if, well, actually, there's not a lot of comparison, so we can just do this. If something equals is 0, if 0 equals that, then wait, then it does this. It jump not 0. Okay, if it doesn't equal that. But last one was Jay-Z, and this one is go to. Right, let's look at this. This one. This is the fifth flat, right? No, this is the fourth one. So what is this lab? 86. 86 is the fifth lab. Okay. This is the first lab. Okay. Fifth. Fifth lab. Okay, so let's go. Let's check here. Oh wait, it is. Oh wait, yeah, I'm wrong. So if it's not equal to 0, then it goes here. Otherwise, it puts this. Okay. So yeah, straight comp does work as expected. Go to lab underscore 001 57 0, which is this right here. Okay. I guess I'll just name it that the exact name. 00101 857. And if otherwise it does this stage 1 of login done. Okay, so this is the username. This is the password. So it checks against this. Okay, so even that password is also root. Cannot be the same. Okay, if it's not equal, then it goes here. Okay, okay. I'm understanding this now. Go to there, and if then if go to there, and if otherwise, then it goes to, then it checks, and it actually puts some stuff in. Okay. Then otherwise, it puts to 8 8. Stage 1 test 2 done. Put this in quotes. God, this is in Windows. Let me just put a semicolon here as well then. Apparently I'm just putting semicolon on just comments that would put a quotation mark in it. That's fine. What's that? And then it checks if it's root. Okay, so if VP underscore 20 if 0 20 root equals 0 equals 0, then go to, oh no, is not equal to 0, then go to disable that. Zero should be, and if, no, not if, sorry. It just says, and the username and password cannot be the same. Okay, so puts data underscore username and password same. Copy data underscore use the user name and be same. Dot okay. And then we have just that, and then we have the next table, which is this one, and we're almost done. Okay, almost done with stage 0. Okay. So then it has puts and now move as lab underscore 00101.829. Then it's time root copy. Well, it just had it over there. Yeah, whatever. This it does steer comp, and then alright, so steer comp dosage V comma, what is it? Local 20, IBP underscore 20 with 1337 equals 0. If not equals 0, right? It's not equal to 0, then it go to go to underscore. I'm pretty sure this is the alias. No, it's not. Okay. Go to that. Please try again as admin. This otherwise it will move into it stage 2 of logging done. Stage 2 of logging in. Puts data underscore 001022E8, which is stage 2 out of 2 of log done. Call stage 1. Okay. Call stage 1. Let's put stage 1. Stage 1. Past. Otherwise it goes to some 157. Copy, paste. It will load. Please try again as admin. Puts data under 102.308. Please try again. Please again admin. Then we have compares 28 to 0. If 28 data VP 28 is not equal to 0. It's equal to 0. Go to lab underscore 00101.879. Okay. Otherwise it does free IBP underscore 28. Okay. Now after we're almost done. After we finish this, we're gonna translate this into actual C. Because so many things are wrong in here. Okay, so and then it compares to 0. 879. Otherwise it freeze, and then it right here is 879, which compares local 20 to 0. If it is, then it jumps to 91. And 91 is, what is 90? No, 91 is here, which is just get car, which checks for a new line. Right? What is it? Yeah, yeah, get car. Check for a new line. If it's not, then just wait. Just keep on getting char. Then once it is, then okay. Okay, so let's see. 79. 79. So it checks if root underscore 20 is equal to 0. 0. Go to this one. Thing. Copy. Otherwise, it's freeze free 20. Then go to this. And we have this label right here, which just calls get char. Get file. So get char is not equal to x. Dragging comment new line. Then it's just going to jump, go to this. Otherwise, it's going to go to 0010116 E, which is first flat. Okay, now we can finally convert. Well, let's actually read through what it's doing. Okay, let's check. Make this full screen. Okay, so let's see. Well, let's not make it full screen. It all the strings right here. Now let's see stage 0. Okay, first it just puts this. Got to comment 28. 28, which should be this one. Control Shift C. Control Shift Okay, so stack cookie, right? Save stack cookie. Then it defines first lab. It prints out to enter the username, then flushes standard out to push it out. Then it checks if it's equal to root or not. It doesn't check it, just this is the definition, and then it gets a character, subtracts it by 30, which is the hex code for 0, which means it's probably trying to compare if it's a number that the user put in. Okay, did I crash? I didn't. Wait, let me just oh, WQ just in case. Just in case I crash. Okay, so it does that. And it's a enter pass, stuff like that. Plus it's the standard out. Root is defined in here. And then it checks if it's is the difference 2, that means the person entered number 2, which is the second lab. So we can actually go there. Let's see what happens when they enter 2. Second lab. When they enter 2, this RBP underscore 28. So second lab, it sees if 0 is not equal to root, then go here. 57. Then it prints that please try again as admin. And if it's 0, then it's not. Okay, so this is probably not the thing that we want to take then. And then if it's not, then it goes to this label, which is this one. So we can condense this into a else if, and this one can be condensed into a while. Okay, so let's do that. Go to this label. If it's that, then if RBP underscore 28 is equal to 0, then it goes to that label. Otherwise, it freezes it and then it goes there. So we just check if it's not equal to 0, then we just condense that into 1. If it's not equal to, sorry, oops, okay, insert. If it's not equal to 0, then do this, be free underscore 28. So now we just have this. We don't need this anymore. And we go there, right? I'm not gonna remove the labels for now, but and then right here it goes to 93 if it's 0. Otherwise it just freezes it and then goes to 93. Same thing as the earlier one. So if it's not equal to 0, then free RBP underscore 20, and then just that's all we need. So we can just read this as a combined block. It first says put try again as admin. If 28 isn't equal to 0, then it freezes it. Then it checks if 20 is equal to 0. If not, then it freezes it. Then it checks if the okay. So right here we can condense into a while loop. So what's this do? It checks if it's not equal to this, right? While it's not equal to new line, it keeps on jumping there. Okay. While get car is not equal to new line, while get underscore get char is not equal to a, which is plus n. Just do new thing. Write a comment, do nothing. But when it does, then it goes back to here, which makes me think that that whole section is a while loop because this is the first label that we have. Okay, so let's just check out everything else then. Then we have, let's see. Okay, so it goes to the third lab if it is greater than 2. Or if it goes to the, okay, we can optimize this for as well. So it goes to the third lab if greater than 2, or it's after. So in any case we can go to the third lab. So we don't need this. Right? Yeah. Okay, we don't need this. And 92, right? Okay. Okay, so let's check out the third lab. Third lab, which is probably over here. 92, 92, 92. Okay, I don't think we named it. Third lab is probably the last one. 93. Where's the third lab? Does anything ever jump to 93? No, it doesn't. Okay, so let's see. Let's see. Get sharp. Okay, wait. 92. Which is this? Okay, this is the third lab. Okay. 92, which is the third lab. Okay, close this again. So it comes there. So that we can probably then move this over there. So since everything seems to be going to the third lab as so the first lab goes to the third lab, and this one also goes to the third lab. This one also goes to the third lab. Only this one does not go. So I'm assuming that this is outside of the while loop. Yeah. Okay, so this is outside of the while loop. $29. When else does something jump to 29? 29, 92. Okay, so nowhere else stuff jumps to 90, 29. So where's 29? Okay, so these this one, third lab is above those ones. Okay. Where when does stuff jump to 57 again? 57. Okay, so I'm just gonna assume this. Third lab is independent, meaning it's just going to run every single time, even if you go here. Only time it won't run is on the second lab when it detects that stage one of two is logging on. Yeah, so okay, so third lab is going to run regardless. Regardless. Okay, yeah. Okay, so let me actually do this. Oh my. Okay, so let's just copy from this part, from this part, copy this, add a while here, while, while true, while one, we're going to be doing this, paste clipboard, and so this is going to run regardless. Okay, fixing this mess. Okay, so it's going to run regardless, right? And did I paste in the third lab yet? Here's the paste. Okay, where's delete this part. I'm actually trying to like compile this. This is why I want to fix all of this, even though now we basically know what the function is doing. Okay, I accidentally did that. I accidentally pasted in the first lab twice. Is there no way to delete faster? Control Shift delete, Alt delete, insert, Alt, Alt. Okay, Alt just locks your mouse. Okay, whatever. This is what we're doing. Okay, let's paste in the third lab one here. Third lab is this. Copy, paste. Are we serious? This is not necessary anymore because we have a while loop. I I can't wait until this compiles, but it's gonna feel so good. Okay. And then what else? Well, we can delete this part because we know that it will work. Okay, so which part? Well, okay, let's do this one. The second lab. Or no, let's do the first. Let's do the fourth lab first because that's the zero. Okay, yeah. Print, enter your username, Malox. We know that that's probably going to be in the if block. Set up this. We have if, and then this needs a else if because no other code runs. I think it's, it's broken again, so we have to fix that. Um, yeah, okay. And this needs a else. This one needs a else if, else if. And we can adjust this part because stuff is equal to zero. Then we do that. Okay. Yeah. Remove this comment. Okay, now this is looking beautiful now. Okay. Fifth lab. Okay, let's paste in the fifth lab in here. Then this part. Instead of calling this actual C, we call this. Wow, bro, this is so little, and I'm so ass that this took me so long to do. This took me yesterday plus today plus 3, not 3 hours, probably around 2 hours today to finish one function, and we still have two more left. I mean, it is true that I'm trying to entirely reverse the whole thing. Okay, so let's get this one. Dude, I can't wait until my title says day 300 of doing this bullshit. That's gonna be so much fun. I'm actually gonna be so proud when that happens. No, but it's kind of gonna be harder though. I should have set like day like 500 because if you think about it, when you're trying to achieve a goal and you set a time frame for it, as you get closer and closer to the time frame, you're gonna feel like you've done enough and you won't want to do anymore because there's not much point. But if I had set it to 500, then I would be like, even at day 300, I would be like, I'm still not done. I still have to go on, and I might make it to day 400. But that's for regular people, though. And we're the boss. We're not regular people. We're gonna accomplish this goal. We can accomplish any goal that we set. Of any dreams that you have, you can accomplish it if you have enough determination, like I do. No, I'm just kidding. I'm probably gonna quit by like day 50. I'm just kidding. I'm never saying that. I'm never saying that again. I'm not saying such profanity again. Okay, anyways, let's ignore what I just said. Let's ignore what I was talking about. Okay, so um what's that? Okay, let's get lab. What is this? Which one is it again? Lab 5? Second lab, okay. Second lab. This whole thing is the second lab, so I might as well just copy this thing. Actually, no. This is after the while loop, right? Stage 1 passed. Oh no, it's not. It's not. It's the whole thing. Because it's not after the while loop. It's still inside the while loop. Okay. I probably don't even need the assembly. I could probably code it at this point. But you know how it goes. Equals, that's the second lab, right? Right. 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 Yep, it is. Okay. Paste. And okay. What is it? 57. 57 is this. Okay. Oh, okay. 57 is where it deletes. Copy. If it is equal to, is equal to. I'm probably doing the opposite because it was supposed to be not. Yeah, I did do the opposite because it should only print. Well, no, I guess I can just add a else. Else. Honestly, that seems a bit corny. Not corny, but past. Paste. Okay. I hope I learn this better someday. I'm terrible at this. there. Ah, there. Okay. Now this is for necessary. Please try again later, and then it frees. Okay, that seems about right. Did I make too much of a space? No. What? Okay, I do know that this is okay, bro. So I need to fix the indentation on here. That's right. Okay. There, 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 and then there, and then else. There. Okay. Wow, that takes long. Okay, so let's read. Let's read. Is this correct? Yep. Stage one passed, and then it goes to stage one. That's fine. Okay. Or does it break after stage one? Does it exit? Stage one. It calls stage one. And immediately after it just says please try again as admin. What? Like I don't understand why would the compiler do that? Because please try again as admin is on here. That's really stupid. Oh, I mean if oh because this part has to be here. That's the only way. Yeah, that part has to be there. So instead of doing this, I have to copy this is equal to that. No, I can copy this part there. Wow, bro. I've been fixing this for so long. can't, I can't, I cannot. Help me, help, 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 help. Okay, finally we have it. Now if I paste, yes, it's good. Okay, first, first compiler, plus. I mean, if it was the programmer, then if it was the compiler, then it would have exited here. But since stage two probably leads to an exit call, that also makes sense. But it doesn't always have to exit, so programmer doesn't care. So programmer intentionally did that. I'll just write compiler. So you never know, you know. It could be with a 0.1% chance, and only on my thing that it was a 0.1% chance. You know? Yeah. Yeah, you do, yes. Okay. Hash. And do stage. This is stage 2, by the way. Lab 2. And now we have lab 2, lab 4. Is this lab 5? Well, no, soon enough. This is this the 5th lab? Oh, we just need this one. So yeah, it is. Okay, so 5th lab is pretty simple. Copy. Now this is gonna mess up everything again. It's fine. It didn't mess up as much as I thought it would. It's good. Okay, we are done. We are done. Now we can remove all the above except for the declarations. Is it? We can just yank it, right? Yeah. Okay. B to here. DD. Oops. Okay. Now I basically have a copy of stage 1, stage 0. I'll just define stage 1 and stage 2 because I don't know if it's going to complain or not. Okay. Void stage 1. Okay. And it's not going to work first time. What do I call it? ECC agent 7.7.c dash O should be, or should it be replica dot x. Yep. as I expected. I knew this was gonna happen. Okay, RBP underscore 20 is a long int. It requires a const star pointer. Yeah, okay. Stack cookie is undefined. Okay, so we're gonna have to do malloc.h lib. Yep, void pointer from that. Okay, stack cookie is gonna say that's 10. 10. Yeah, so this is going to be 10. This is undefined. Printf smash stack. You'll probably never get this because memory might be arranged differently. Is there a stack cookie? Okay, okay. I should just remove this stack cookie, but I'll keep it because it's funny. It's a pathetic little implementation of a stack cookie. Malloc free. Okay, this should be RBP. The other stuff will be a const star pointer. Const star pointer. RBP. Const char. It should just be a char pointer, not a const char. Oh, which one was it? Why did it never use 18, by the way? That's a little bit scary. RBP 28, 20, 20. Okay, it never uses 18. So maybe 18 is something that we have to modify. Okay. Char pointer. 28 is also a char. Can I do GCC? Okay. This is just a note. Error if lab. Where am I doing labels? Warning. Printf malloc. How do you want me to declare it? It's because I forgot to include stdlib, right? Yeah, okay. Because I was just talking about that earlier. No way, I just forgot lib.h. I'm not sure like there's any order between how do I including that, how do I include that. Like I included stdio first and stdlib. I'm not sure if that's fine or not. Okay, error again. At least there's less error. Stage 0 makes sense. Minus that cookie is equal to 0. That cookie is just 10. This is steer comp include string.h. Okay, and this is stage 1, and then the print if is an error. Label used but not defined. Okay. Okay, so what are the errors again? I forgot everything. Okay, well, first let me include string.h for strcomp and stuff like that. String.h, and we have, okay, yep, right here. If it's equal to this, then you do that. You do this part is equal to that. Then go to 29, right? If it's not equal to 0, 29 is right here. And then it just it continues. Okay. Continue. Okay. And then we have stage 1. Dude, stage 1 is defined. Oh, it's not because it's stage underscore 1. Stack cookie stage underscore 0. Stack cookie 10. 10. Okay, what was says right here? And where's print? I did print instead of printf. Printf is there. Printf. Print. Printf. Do nothing. Okay, that should be it, right? Okay, there's one more error. L value expected. If steer comp. Okay, it's because I did this. Oops. Insert. Escape. Oh, WQ. Now, okay, there's an error. Undefined reference in function stage 0. There's an undefined reference to stage 1. Stage underscore 1. That does exist and it is defined. Right? Stage underscore 1. Are you saying that this doesn't count as a definition? It's because it exists. Okay. Now, if this doesn't crash my system, so replica. Okay. 2. Bro. Seg fault. Okay, let's see why that is. 2. When I do 2, why does it seg fault? Why does it seg fault? Equals 2. And it puts that. It's because it tries to compare nothing to root. Okay. if I make a username, then John, and then I try to log in, it shouldn't sec. I spoke too soon. Okay, if I make a username and then I make a password, uh, and then I make it, I log in, segfault. Steer comp to there. Equals 2, then if it's equal to root, okay, let me try to make it root. WQ 0 root 0 root 0. Okay, wait. Okay, there seems to be a bit of logic errors here. Okay, so it checks if it's root. Okay, so as soon as I enter my username, then if it compares to 0, I cannot type in root. Is it consistent with this? So it compares it to 0, right? Where does it compare? Is it here? Yeah, okay. Compared to 0, test ex. Enter your username, print f, and then flush it. Malloc takes it in. Leah move call steer comp. This is root. Test ex. If it's not equal to 0, then it jumps to 92. I forgot what 92 is. If it's not equal to 0, then it jumps to 92. Was I actually supposed to do that? Oh, no. This is correct. This is correct. It's correct. Okay. And then it puts, and then it frees, right? Okay, now let's try to execute the other program then. What does it do? How is mine not good enough, huh? Says agent. Um, if I type 0 root, you are not allowed to. If I type login with a segfault, yep, okay, it's same. Okay, well we know that we can enter a password and it does. Well, we can enter any of the two, and then it does actually do some stuff because we can see that right here. Okay, let's see how we can hack this without patching. We can. Well, it does. It compares to root. Stage 1 of 2 is done. If I type login and we have root here. Oh, okay, so we have to put in root without ever, and we know this is we know the password. That's good, but we have to put in root inside of rbp underscore 28 without ever putting in root directly. So how can we do that? Or does it take any other input? No. And RBP underscore 20 is more far. So it's not gonna be able to overwrite that. Otherwise we can use the otherwise we could have used the scanf, but since if we overwrite this and it checks the whole string. Um so we just have to bypass this one effectively. Not effectively, directly. How do we bypass this? How do we bypass this check steer comp 28 to root? Because it's gonna free my buffer every single time. And it doesn't even give me like anything else. What is this one? It takes in, it just scans F and it doesn't care. Is there a way, since this one is taking in, well actually wait, I can never exploit the stack because this is, it scans into the heap and it scans anything. It doesn't care about the size. So what if we overflow? What if we overflow more than 100 bytes? What would happen? Well, we can have like enough bytes to reach into the stack. Well, that would not that wouldn't work because it goes into higher addresses. Wait, but it could because the stack is higher up from the heap. But that would take too many characters though. So, is there anything we can do here? Do we have to go through stage? We have to go through this part. We have to go through I'm pretty sure we do have to go through right here. But the question is how without does it ever does it ever leak what I type in there? Because then we might be able to use printf. Okay, well we know that we can overflow the heap, but I don't know how to use that. What can we do when we overflow the heap? Um, is there a way we could get the address of the stack? But that won't do anything. Okay, how can you use a heap overflow? I don't know. I don't know anything about how to use it. So we can search up memory structure of a program. Then maybe there's something we can use. Okay, so there's a heap and the stack is all the way up there and it goes towards the lower address. Heap grows towards higher address. What is between heap and the stack? Well, if we know that ASLR is disabled, right? WQ. Is ASLR file as agent X. It's can we see what type of thing it is? Is it, do I have to do, what is read elf dash H agent? Okay. Now we can see that it's protected or not. What is a read elf dash? Oh, okay. Um, all file header, program header, section headers. Okay. How do you view a type of file? File agent. Okay, okay, that's how. Okay, so it's, how do you see pi executable? Is there ASLR? How do you check? How to check if something has ASLR? I think I can do that. How to check? Because I'm pretty sure the data section is between heap. Okay, never mind. Is the RO section between those? Because then if, okay, so I'm thinking this vim vim, right? And then what if, well, if the RO section is over there, then, well, we're gonna know what was between heap and the stack. Linux heap dynamic data. There's nothing between heap and the stack. And memory mapped segments. Shared libraries are between that. Okay. Well, we can if there's no ASLR, then we can just leak that. Yeah, let's just search it up. How to exploit heap overflow. Yeah, let's see. CTF 101. Much like is a vulnerability where it fit in the, this could lead to heap metadata. Heap metadata. Okay, let's search up heap. Refers to internal data structure used by track. Used after free is free called the allocator. This could lead to a corruption of other heap objects. Okay. How do you leak, how, wait, what's the protection that gives pointers, that gives the stack? Well, that doesn't matter. Just where the program is loaded. It's the protection that changes address of stack every. This is ASLR, I think. Yeah, ASLR. Okay, how to check if ASLR is enabled? Linux. Enable Linux for a program. Not my high protection, meaning Okay, so it does have pi, but that doesn't change the base address. That doesn't change the base address. So the return pointer. You can use format strings, but there's no like format string. Is there any format string on here? It calls this is ours, so this one doesn't count, but it calls printf right here, and it calls printf right there, and it does scanf dash I mean string scanf string. Does this format mean anything? Because it's also true that this function is never going to return. Use after free s2 malloc read use after. Dynamic heap overflow. Okay, sometimes can transfer. Like we don't have any vtables. This is not. It's not. It's placing one buffers to make a heap look like this. How can we do this? This sounds interesting. This one. Format string. This one. This one. Sophisticated JavaScript. Sophisticated. Sophisticated. Heap overflow. Memset heap A64. Okay, this is indeed an overflow. Okay. In a debugger, presented with kidding due to fill, resulting in this modern system pretty much okay. So what can you do? Shrunk. Okay, you know what? We might have to watch. I might have to watch Deep Overflow by Live Overflow. Okay, I hear. You have to watch a tutorial. I mean, I can kind of understand though. If we can, like it just depends on where the two things are that we create. Where the two blocks that we create are. Okay, let's just see what he does. Because I can think that if we find the other thing, then we can overflow into the other one. Let me turn this off. I'm just gonna do this on here. I'm just gonna watch this like somewhere else because I don't want to get copyrighted by Live Overflow. That'd be terrible. Okay, let me mute my mic. actually decided that I'm not actually gonna be watching the tutorial because I somewhat know what's going on. I actually kind of somewhat know what's going on because well we already know there's a heap overflow and I know that to pass stage one I have to do this. Unless I don't have to, in which case I know that even that's possible because we already have a vulnerability and that's gonna like allow us to do anything. And it's not even like restricted or anything, so yeah. But I know that this is probably the easy way to just to adhere to these rules but break the ones about the heap because then that's gonna be easy. Okay, so let's try. Let's because I thought GDB was like a cheat code, but it's just like a tool that you use. Set this assembly play for. Yeah, yeah, because that's what I thought. I thought like, I mean, I know it would probably be possible as well, even if I don't use GDB, but still, break main. Okay, if I just run it, continue, run, and do display slash, and I did this pen PC, and then I'm just gonna break at break at stage 0. Oops. Okay, break br delete delete br. There's 3, 4, 5, and 6. Just for br. Okay, main and then stage. Okay, let me just delete br1, delete br2 so that I can just make a br at stage 0. Okay, info br. This is why is it number 7? Okay, br stage 0, 1. Okay, and info br. Okay, now we can continue. Okay, this is in stage 0. Now let's ni and then again and then again 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 enter password stuff. Okay, let me just enter my password then. Oh wait, not enter my password. Enter, yeah, yeah, that's what I mean. Enter my password. Enter my password, and then ni, right? And then ni is gonna check which one I want to do, and then it jumps to my password. Root, I don't think I can ever mess with root. Well, I mean I could, because then that's how I can write password. But I don't have password already created, so hmm. So I think the goal is just to write password first and then write the root. I don't know. Okay, probably. So ni again, and then we are at a new place. It does malloc. So we have to print out the address of malloc. Okay, let's print out xsw qw. This is W. Rex. What? So NI. Are you saying it's gonna happen this time? Did I crash? Oh, I didn't. Okay. Now if I go again and then if I type Rex, okay, we know it's the same address. Not NI. And then RSI. And it's 30. Okay. Makes sense. And then we go to NI. NI again. NI again. Is going to ask for a scanf. Oh wait. Does it ever free before asking me? No, it just mallocs and then leaves the memory. So you're telling me we can do two different things. We can keep on mallocing memory. Okay, so let's open up Obsidian. This is too important of a news, bro. Not only one exploit, but two different, not exploits, but vulnerability in stage 0. Dude, two different bones. Not only does it allow me overflow, it allows me to create multiple buffers and all multiple heap buffers and all of them can over. Okay, so I just need to do this. I need to spray the heap, not spray, but okay, I kind of know now. Okay, so I have to basically put root into a free block. Okay, wait, can I see the process memory and stuff in here? Let's see. Wait, let me actually ask my coach if it's illegal to do that or not. And my coach is just ChatGPT. Okay, wait, wait. What? Hmm. Okay, so it depends on this fact. So if we are going to be overwriting something, we have to check the memory address, right? And I'm not like getting this from anywhere. This is just me, right? And we know that we can make a different buffer every single time for the password and the username too. But my goal is to write to the username the value of root because that's the goal, right? So we have to check where the username is. So it was dumb to do that. It was dumb to create that. It was dumb to create a thing. So let me actually just run again. So, okay, let's just run again. In info, yep, there is info breakpoint. Okay, so step step. Step. Okay, we can type 0 for username, right? Because we can't enter root. Okay, 0, and then we have next, next. Okay, we are here now, and now it's gonna malloc. Now we can view what is at this memory. I actually thought that using GDB was a cheat, and you shouldn't do that. But I know that you're meant to use every single tool at your disposal. And let's look at what is at XSW or RSI. Cannot. What about just RSI? Okay, what about RSP? Okay. That doesn't matter because I don't care about that. XSW. Okay, so I realized that, okay, this is what I realized, okay? If you're afraid of me to use debuggers because you think it's too powerful, you shouldn't be. As long as you have, as long as you've done this part, sorry, this part, to map out everything about the code, then you know the exploits in there, then you're good. Because if there was something for detecting debuggers in another program, then it would just then it wouldn't, like, you would be able to exploit that. You'd be able to patch it in here. You'd know which code it is, and you'd be able to like decrypt everything as long as you practice this part, which is why I think this part is the most important, and that's also why I'm taking so much time to do this, because I know this is really easy to do, but I know that as long as I get better, it's gonna be really useful in the future. This is the most valuable tool to be able to do this and do it quick, because I took around what, if I count yesterday, that's around 3 hour 20 minute to do this. Yeah. Okay, so anyway, as I was okay, anyway, enough of the philosophical rant. Okay, so let's RAX, and now I can step NI, and then NI again. Wait. What is okay? This is the thing. Let me just save this into. Right, and now if I do XSW RSI, okay, it's something else because the function probably replaced it, right? Do we call the function RSI? RSI RX. Oh, it's not done yet. Okay, so we're gonna be able to do it now. Okay, that's the address. We have to know that. Next, and then next, next. Okay, now we just put anything that's not root, and now it works. Next, next, next. Okay, where are we at? We at jump. You just have to type a new line on here, I think. Okay, it should do the same thing, but it should flush and then do it. Enter username again, and then we have like, okay, wait, my bad. Get char. Um. All right. Okay. So what are we going to do now? Well, we know the address. So we're going to enter the password now, and then we're going to subtract the difference of in hex of the two things. Or is it mallocing? Malloc. Let's find malloc. 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 And if I didn't do the C code, I wouldn't be able to do this freely. I wouldn't be able to step in freely without analyzing this part. Because I might have to be worried about the debuggers and what code is running, but now I basically know everything that it's doing. So, and it probably doesn't matter for because this one is so easy, but I know in higher level it does matter. So, okay, so ni again. Wait, yeah, ni. Then just enter, and then okay, let's print out xsw. All right, x is 0, right? Okay, let's see the difference between those. We already have this one minus copy section. Oh, and if we look at this address, this one, we can probably see xsw at this address. Oops. So that is the correct address, but more stuff mixed in. Okay, if we can't access that. Okay, we can access that now. 65 779 300. So let's see. So this is at 30, 31, 32, 33. Or this could be, or this is at, yeah, that's it, yeah. This is at 30, 31, 32, 30, 31, 32. Okay, so do we enter 3 words? Username, enter username, that. Enter username, we pressed 1, right? Yeah, 1 to enter my username, and then we got 2. We got to there, malloc, and then scanf. Well, we're not, do we not, are we not there yet, or what? What? Wait, what? Because this is the password one. So did we already do scanf? Oh yeah, we that was earlier. Okay. Yeah. Where is it? Let's find it. Enter DDD. Okay. DDD. This is what we entered, right? Now, how does that, oh, DDD and a new line. So how does that correlate with what we typed? This is not DDD. at A. Okay, this is comma plus 2 plus 1 minus 30 plus 10. Well, how do I go from this to more? Ugh, how do print? Cause that should be the address, right? X slash giant. Okay, so 10 from here. 10 giants. So just this minus 10. Minus 16. Okay, from 20, there's a 13, 113, 113, and then, okay. How is that DDD? Oh, because it's lowercase. But that doesn't mean anything. Is this in hex? 10 giants, right? Yeah, this is in hex. 113. But it starts at 30 though. The address is at 30. Alright, is this another address to something? How does this work? Okay, let's just see. String. And it should be exactly as this. 1 1 1 3. Nothing. Okay. Unless it's a number. I mean, I'm not seeing any F's or anything like that, so maybe it is a number. 6579. 6579. What else? 6579. 79 300 300. EYO. If I add a 133, wait, is that's at a lower address. So if it started, then it would start 1 1. It would go 3 0 1 1 1 1 3 0. But that's still not decimal to string. Um, unless it saves a different format, but that shouldn't be the case. Okay, 6579. This is a Chinese character. Dude, okay. How do I print out a string? How to print a string? It in DDV. X slash S. Hey, treat an address as a string. Okay. XSS XS10S. Oh, is that a different address? 59B30. I don't understand. I know that that's correct, but I don't understand. I don't understand. Okay, wait. Did I erase? Okay, I didn't erase. But how does this 10? But I don't want a string anymore. I just want 10x. Okay, now why is it different now? Why was it showing 60 something else? It was showing this XS 10G. If I do XS 10G, bro, I hate this. Okay, whatever. Maybe it only got updated right now. Okay. XSWRX. Is this BA0? Okay, it is. Okay, let's see the current instructions. XS10 IPC. Okay, let's go to next one. Next one. Okay, right here is where we have to be careful. Well, not careful, but -70. Okay, bro. So it really put it at a different address. So this address is higher. Minus. So if I start printing from there, 9BA0. So that's at a higher address. And heap, not heap, just it's just gonna be placed at a higher address. So do I just have to make a new thing, I guess? Okay. Lol, hi there, memory. How are you doing today? And now we can see excess W from, oops, excess, how many? How much is 70? 7 times 16. Well, 16 times 6 is 96. So 112. 1112. Not 1112. Let's do 128. 128x. Let's look at the numbers first and then we can look at the string. 128x and then we do this address B30. This is where I'm at. Oh, is that too much? Is it because this is considered 1? Okay. So we should have just done 70 then. Quit. 70. That's also too much, but that's fine. 64, and then right here we can see it has this thing, XS70S. Continue. 78. BA0. Okay, that's not enough. Okay. Then I guess this have to go to 300. Continue. B A B E D C B A. Right here we have it. I guess it's not loaded into memory yet. Okay, so that's what happened last time too. It just wasn't loaded into memory. Next, next, next. Compare, 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 here, compare, 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 compare. Bro, I'm stuck in an infinite loop. How do I exit the loop? Uh, we're in a bit of a trouble, guys. Okay, how do I input? Because this is what the problem is. Get car isn't working. How do I input? How do input keyboard interrupt into GDB? No, I don't want to end the program. Jump not equal to. Okay, you know what? We might have to patch this. Can we write to this address and just make it jump? IP. Out to set 90 90 90. Okay, this is what I want. Char 3. How many bytes is this? 54. Well, this seems to be in decimal, so 54. I mean 64 to 566. How many bytes is that? That's that's just 2 bytes. How many bytes is NOP? How many bytes is a NOP? 1 byte. Okay, so I just have to do that twice. Okay, char 2, right? And what is this? Res We have that. Okay. No way I have to patch because this thing is broken or something. How is it not causing? Equal to 0x90, 0x90. Okay, that should work. Now if I do PC, call it, and then 4. Okay, let's go. Wait, what? Oh no, I might have messed some stuff up. Calls, and then knobs. Calls, compares, and then knobs. That's not what I wanted. Do I have to move a 0, 9 into there? 580, 89, 98. Oh well, it was 89, 89, and then not, and then instead of that, it should be 8 equals 0, 9, 0, 9. Okay, if I do that, will it work? Okay, this is, oh, what is this? What is that thing that you have? What is it called? I'm having a post nut clarity right now. Okay, almost. If I change this, 9A, okay. 9A, 9A, just 9A, just 1 byte. That is not 1 byte. That costs a whole, bro, that costs how much? Like 59 to 65. Okay, let's just try to patch 59 and see what happens. 50, 98. Oh shoot, if it's from 89A. 89A equals 90. Char 1. Should that work? That should work, right? Okay, it compares. That's not bad. RBP minus 21. Wait, does it have enough space to do that? Okay, let's see. RBP minus 21. RBP. Is it as username? Oh yeah, it does. Okay, we're good. Close that out. Okay, we're good. Yeah. Okay, wait, it doesn't matter. Okay. Okay, we're good. Okay, then NI, and it should hopefully not crash, right? NI, NI, okay. Nope, 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 nope. That shouldn't crash. Nope again. Nope, nope. Jump. Okay, we are back, guys. We are back. Okay, so now wait, let's print out stuff. Print out this. Where is it at? Okay, here. 300S from there. Yep. Continue. We should see high lol. Q lol. We only have Q lol. Okay, okay, we just have to make another pointer then. Ni, 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 ni. Oh wait, did I just skip over the call? Wait, but I'm supposed to skip over the call. Break, break right here. Copy. Break at this address. Paste. Continue. Why is it broken? Bro. Okay. Set this assembly flavor into, okay, we were having too much issues on the last one. Display. That's 10 I PC. Error, no registers. That's fine. Let's go. Continue. Sorry. Run. Okay. Now we can do enter username. 0. Let's run again. Control C. Oh, okay, let's run again, but this time break at step 0. Break at stage 0. Okay, run. Okay. Okay, we have enter username. What will my username be? It will be scanf. Should be just user. It doesn't matter. We're gonna replace this. I mean, it has to be a 4-letter word because otherwise it's gonna not work. Is it for including the new line or for? I think it's for excluding new line. Okay. Because then it's gonna place a 0 in there, user, and then x w or x. Wait. Right, bro. How is Rx equal to 1? Ni. Okay. And even this is wrong, but it's fine. Like, what? Where is this memory that is showing me from? So I guess the address didn't change. BA0. 9B3. Okay, it did change. 9B30. No, it didn't change. Okay, that's nice. So is there no? There's no SLR then, and even with that, I still can't break it. So there must be something wrong with me. It's almost time to take the next break. Yeah. And I 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 and I. We're going to enter the password this time. Oops. Enter password. One. Okay. Wait, what? Wait. Scan F. Malloc, right? Oh, okay. X/W RX BA0 again. That's not what we want. Let's go ahead. Random. Okay, finally get card didn't break. Now we can enter something again. Oops, sorry. Oh wait. What? Oh yeah, one. Okay. N I N I. Let's see where it allocates. This time XSWRAX C10. What's the difference? C. Okay, wrong. Address. Copy. C10. E0. Bro, are we serious? Okay. Next, 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 next. RRR. Again. Next, 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 next. What is it good? What is it print? Okay. And then this time, please enter. Next, 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 next. Mm, 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 mm. Okay, wait. It didn't malloc yet. Okay. Wait for that. Now I can do this. XSWRX C80 B30 C. Dude, is higher. So do you like? Should I get a different? Should I try to malloc the other one? Da 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 da. Uh, 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 uh. Okay, next, 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 flush. Okay, we're gonna do 0 this time. Next, 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 next. Malloc. We have XSW RAX. We have CF0. Okay, that's a much higher address and much better for me. CF0. Okay. We just need this address to be lower than this one. Okay. NI, 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 any four-letter word, root again. Toot, toot. This is the second root. NI, NI, NI. Dude, no way this is stage one, and I saw in the comments people were saying the later parts were harder, so NI, 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 an I for an I. Okay, one. Okay, bro. NI, one. Malak, where's Malak? Malak, 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 Malak. Malak, okay. XSW. Please. D60. I just want to believe that it's higher, bro. I really want to believe that it's higher. Fuck you. We're getting demonetized even though we are never monetized and we were never monetized because I have 0 viewers. And what am I doing with my life right now? And it's 4:45. Well, we've been recording for 4:45. Not that it's actually 4:45. Okay, one. This one better be the one. Okay. Okay, XSW. Alright. Bro, it's because the like later the previous addresses were all filled up by the heap. So do you want me to do root? String multiplier. Okay, root. Oh, this is 4. 100 divided by 4. I just need 25 to be 100, right? So then we can do 26 to make it more. Paste clipboard. Now, if we should, the next address, I hope, lands better. Oh, wait. Ni, 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 Ni. Okay. Paste. That should be more than 100 characters. Character count. That is 104. Okay, that's good. Okay. Now if we allocate for the root again, if we allocate for admin again, then we should have the correct stuff. Enter username. Wait, does malloc clear out memory? Okay. Then that's everything about C is a vulnerability, bro. Even malloc doesn't clear out stuff. 0. Now let's see what address it gives us this time. Hopefully, wait. It's D60, right? XSS. This address it should show us root. If it's not, then okay, that's different. We need to find the correct one. What did we type? We typed 0. It's not it. Where's root? Times 100. And it's here. Where's the address? This one. Copy. This is our favorite address because it has root everywhere. Wait, what is the difference between D60 and this one? Is if it's 100, 70, right? Maybe that's a hint. We can see if how many stuff it allocates. Ni. Is it saying enter my username? Malloc XFW RAX, and is this E40, and it doesn't contain root. E40 minus DD0, 40 minus this amount, 70. Oh, okay. And how much? I know that hex 64 to decimal. That's 100, right? Yes, that is 100. So I need to go 8. So we need to go 16 bytes above that. So one root isn't enough. We need 4 more. Repeat. This 26 would be 4 bytes into there. 27 would be 5 bytes into there. 27 would be, well, 26 would be 4 bytes. 27 would be 8 bytes into there. 28 would be 16 bytes into there. Sorry, 12 bytes into there. And then 29 would get to a 16. So we need 30. Copy. This should be it, right? Okay. Well, we know we're gonna have to make a new password. So every time is 70 bytes. Enter username or enter password. We're going to be entering the password. So it was so simple all along. And let's just print out XSW RAX just for good measures. And let me save this here. EB0. Okay. Now we copy this. Then we paste clipboard. Don't want to mess. Okay. Or I cannot even go up. Are we serious? Is this what I have to work with? OOT. Okay, I'm just gonna hope for the best and say that that's gonna be root, right? Okay. Check out the memory at the address. What was the address? It was this one. Scanf doesn't work instantly though, I think. So we're gonna have to wait a bit and then we're gonna have to go there. Okay, now access S at this address. We should have root and we should have 116 characters. 120 characters. Okay. Okay. Hopefully. String counter. That's only 95, bro. Okay. Plus, no, sorry. 10s from here. At EB0 is that. Oh no, 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 no. Okay, unless, okay, what is the difference between EB0 and F10? F10, EB0 and F10. It's only 60. No, we were 16 bytes away. So we needed how much more? We needed 4 more characters. Well, no, actually. Wait, yes. Okay, wait, let's see where it mallocs, then we're gonna find out. Okay, just straight go to the username. Sorry, 0 until we get to malloc. Okay, XSW RAX. No, we were so close. F20, F10. Yeah, we were exactly 16 bytes away. Bro. No, not even that. We were 20 bytes away. Because to F10, it's that. Bro, okay. Okay, whatever. Okay, let's do it again. We have to do it. Oh, wait. Oh, wait. This one creates, this one also can do it. Because this one also creates a 120, 120, no, I mean 100 bytes. So we have to do the same thing here. So character counter. character 120. Okay. Copy this. One line, right? This is one line. Okay. Now it's asking for my name. Paste. And that better be it. If I now go and then XSW RAX repeats 30 times. Wait, XSW RAX. Yes, this is perfect. Okay, now we just do it again. We create a memory and we put nothing in there. No, but it checks the string. It checks the string. So how are you supposed to do this? Wait, how are you supposed to do this if it checks the string right after? Well, at least we did it to that point. Okay. Is there any way at all to make a new thing? Make a new assign the thing to the thing? Because I know it's gonna work this time, but how do I make it so that it mm, these are good questions. Enter username. If I know it's oh, how am I supposed to do it, bro? Okay. Let me give me a second. Okay, I'm gonna be back in like 30 minutes again because I gotta stretch as well. Finally, yes. Let's go. Bro, I did not know I had to use a use after free thing. Bro, I should have guessed that earlier, but still though, it's still like still kind of it's not confusing, but I mean, I guess it makes sense because every time we write to the username, it gets checked. So we have to write it in a subtle way. So by still having the username point to the freed pointer, but now we rewrite that the other one. Okay, that makes sense. And the fact that it's not just a clean answer, and the fact that we have to do all of this and rely on the fact that the malloc will will do that and like a bit of luck, I guess, because this is basically like this is shows that not like hacking never has a clean answer, I guess. Wait, what is that? What is that? Is now you must to unlock the code is gonna be must change. Okay, well, ABC. Oh well, at least we got that. We got to the clear. Okay. Okay, wait. Let's try it again because that's fun. Okay. One. And by the way, I didn't get a help at all, like or anything. The only hint I took was that well, it wasn't even a hint from like the app itself. I asked I asked AI to give me a hint without making it subtle, and it just told me to think about what changes when you or where you're writing to when you allocate and stuff. That's the only hint I got. Yeah, and I took that hint because it was taking too long. But yeah, okay. So let's do it again. Okay, first set a username, and then we free that to this one. I mean, we do this, and then we set a password, right? This one doesn't matter because this one gonna get freed. So two, log in. Now both of them are freed, but username is still pointing to the or username is still pointing to the freed pointer. So in that case, it's gonna treat it as freed, and every time we create a password, we have to remember that it mallocs every time we create a password. You see how every time we create a password, it's going to reallocate right here. Well, and yeah, right here, it would free my thing if I wrote down root, but if I this one is the password it mallocates and it just pulls it into a buffer, right? It doesn't free or anything. So yeah, that's all. That's how you solve a stage one. I can't believe that took like how much did that take? That took long, bro. 5 hours. Okay, realistically probably 4 hour 30 minutes because I'm also like goofing around a bit, but yeah. Damn, bro. Okay. Um. Okay, I'll just say it took 5 hours, I guess. 5 hour 30 minutes. That's my benchmark for cracking stage one without help. Um. And probably a bit of help because my brain probably got a even like unconsciously my brain probably got a intuition from looking at that document about heap heap exploits, and it was and also from this like how I'm going into this. So yeah, but I never thought about use after free because I thought it would have freed. I didn't check the fact that it doesn't free when you log in. It just clears the buffers. I mean, it does free, but it doesn't set the pointer to zeros. Yeah, your password. That really shows like how easy it is to come with a vulnerability, and that shows how. Okay, I'm talking too much. This is a beginner challenge, bro. I'm acting like this too much. Okay. Two, two, three. Oh wait, I already did that. Now I enter a password. Wait. Oh no. I hope that didn't go into the thing. I'll just keep doing root. I don't think it did though. So I hope it didn't. And then log in. Okay, well, okay, I guess let me just try to make a new username then. Because I think this will work again if I try to make a new username. And then I tried to log in. Ha 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 ha. Two. And then I keep on entering root. One root. One root. Oh, is it because earlier I didn't enter the correct password? Yeah, that's why. Yeah, because it says stage 1 of 2 login and done. Log A is done. Okay. Oops. And it did detect the fact that I did root. And it freed the buffers probably, so I'm gonna have to log in again. Or no, I'm gonna have to write my password again. Root, root, root. Okay, now this time I won't forget to paste the password. Wait, I'm root. One is to enter password, paste, and then two login. Yay! Change your secret device. Use your secret device to change the code to unlock the door. And you must change it. My secret device. Is this thing I have to use? I have to patch it. Oh my god. Okay, I don't wanna guys, I think this is it for today, honestly. Wow, this is a lot. Fact stage. Let me also do like let me also copy this thing. It's not it. Wait, so in here it should work as well. No probably not because it has different protections. Replica. Okay, whoops. Everything is getting slow. Let me close all this because I don't know what just happened. Why is my CPU spike so high? Okay, it's done. Whoa, bro. What's going on? It's so slow. Dude, I have to clean my fan for my PC sometimes because it's dusty. Ugh, I just sneezed. Bless you. Close, 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 close. Close, please close. No, it's not closing. Can I go to 2? Wow, it is so slow, bro. My PC works, just my VM is slow. start working again. Okay, don't know what's going on. Okay, you know what? Go back here. Go back here. Something is breaking inside here. Dude, Kali Linux is unstable. I don't want to make fun of it because this is my first thing and I don't know. Maybe I should start using this as a main, like Kali as my main instead of Windows. Um, yeah, maybe that would fix it. I actually want to get the thing. I want to get like Linux Mint because that one seems good. It seems stable and stuff. Um, oh wow. Okay. Is it because there's something running in my terminal? Oh yeah, that was probably why. It's not. That was not why. It's because of this folder. Okay. Was it because of that? No, this is my whole machine. My whole, not my machine. My Kali Linux. Um, okay, what can I do? I don't want to file close. What if I send this on shut down signal? It is closing. Okay, restart. Do I have any browsers open? No. Wow, why did it take so much stuff? So much resources and stuff. I want a Linux where you can run Minecraft because that's what I'm super. Arch Linux. Are you serious? Can you run? Yeah, I heard Arch is actually good for gaming. Can you run Red Dead Redemption 2 Arch? Okay. Dude, I'm serious about that too. Wait, let me look at what I have on my desktop right now, cause that's gonna like I have my YouTube stuff. I have editors, video editor. I have honestly like nothing else that important. Yeah, I should get Arch. I should get Arch. But I'm not gonna decide that right now. Though. I'm not. I'm gonna have to like save my all my stuff to a USB and then import it back to Arch. Yeah. Wait, is Arch secure? Is Arch secure? I want to run Arch and then run a VM on Arch. Is V is can you run a VM on Arch? Dude, it's basically good. It's good. Okay, I'm gonna do that right after I stop my stream. I'm gonna install Arch to play Minecraft. Okay, so where were we at? Oh yeah, I was gonna just log, not log, but yeah. Tomorrow I'm planning to just reverse the whole agent thing, and hopefully this time I'm gonna reverse faster. Um, wait, what was that plan? Oh yeah, I was trying to move agent to my thing. Okay, so copy. Wait, can I obj dump object dump dash d agent? Alright, look at main. Did I dump everything? Okay, why this looks kind of awkward. Yeah, that's good. Um, what's it? Obj dump dot x. What if I just dump like that? Dash d lowercase d. Okay, that dumps everything. Main dash. So is that? Oh my! Am I lagging again? Intel. Was it really that quick? I refuse to believe it. Yes, not. It was that quick. How do you set to Linux? I mean, how do you set to? How do you set to? How to what is it? How to only I just want to dump it because I want to analyze and disassemble. Okay, paste, disassemble. I'll be right back. Hold on. treat item if no commands are specified. How do I use this? So you can pass this as the command. Okay. And xargs into echo pipe to file. Overwrite a file. Okay. I'm going to agent main, and I'm going to xargs right there. Right? Is that good? I think this is good. Okay, so if I do ls, there is no main, but there is agent, cat agent, agent A. Okay, let's go. Okay, now same thing, but for I'm going to append it, and I'm going to disassemble stage 0. Okay, well, I think they already ran half of the command, right? Or most of the command. Ls, okay, cat, yep, and section.pot, pot, what? Let's just run that part to see what it gives me. What is this? Stage 0, disassembly. Okay, it doesn't give me any of those. Output print execute to the standard error. Well, clear. Now we have cat. Okay. Now I can CP this file. Agent ASM to sudo copy from desktop. Let's copy desktop directory. I can do it. I can do command prompt. Alright, and then ASM clear ls. Okay, it's clean. Now we're good. Okay, well, this is it for today. guys. This is it. Okay.